Hey guys, this is 14.4 for the integrated rate laws. We're looking at an equation here that's going to come up pretty often. This is for first order. So when we looked at the previous screencast for 14.3, and you saw that they were all for first order reactants, that's what this is referring to. First order reactants would have this is a natural log. This is the concentration of A at whatever the time is, and this is the concentration of A at the initial time. So if you take the concentration of A at time T, which of course shows up over here, divided by the initial concentration, and take the natural log of that, then you can find obviously the T at any time and the concentration at that time. So A0 is the initial concentration of A. A sub T is the concentration of A at some time. So the concentration of A at some time T has to match up to the T that's over there. So this is confusing, so we're going to do some example problems in a different screencast so you can see what it looks like. So the integrated rate law looks like this. Manipulating this equation, when we move, you know that you can do this from pre-calc, where you can separate them to minus natural log of A at time at concentration at time minus the natural log of the initial concentration equals this. And then if we move this to the other side, the initial concentration to the other side, where we add both sides to the natural log of the initial concentration, then I get this equation. And notice that it looks very much like y equals mx plus b, which is an equation for a line. So let's take a look. So the first order process, the y, the mx, the m in this case is the negative k, and the x is the t, and then of course we have the natural log as the b-intercept, the y-intercept. So therefore, it is a reaction of first order, a plot of the natural log. This is key. I'm going to use a different color to make sure that you see this. Natural log of A versus time will give you a straight line for a first order. Okay, a straight line. Good. And the slope of that line will be the negative k. Okay, so take a look at our first order process of methyl isonitrile that's this compound right here, goes to acetonitrile, okay, which is this compound right here. Doesn't look like much of a difference, but there is a difference between the two. So this is a first order process. So when I graph the pressure over the time, notice it's not a straight line, okay, but if I use my equation to change pressure, which you can also do concentration of that. You can also do the concentration of that. Pressure and concentration, okay, are the same in this sense. And if I do the natural log of the pressure, notice that I have a straight line. And that's how we can tell that it's first order, because of the natural log versus time. Natural log of the pressure of this CH3NC versus time is straight, and that's how we know. Okay, therefore the process is first order, and K is the negative slope of this right here. And they found that by obviously using some points on the line to find K. Okay, that's 14.5, so I'm going to stop there.